Hello, Honors Pre-Calculus. I am sorry that I cannot be with you today, but you have a video which is almost just as good. So here we go. If you need to pause this video at any time, just if you're watching it at home, you can do that yourself. Here in class, if there's a part that I don't give enough time for you to write something down, just ask Ms. Vickery to pause it, and she can do that for you. Before we talk about what a hyperbola is, I do want to remind you what point-slope form is for a line. Remember, if you have slope and you have a point that is on the line, then you can write the equation of your line as y minus the y coordinate equals slope times x minus the x coordinate. Okay? We are going to use this when we talk about hyperbolas. So if you don't remember this formula, you may need to write it down. Okay? Anytime that I ask you to write the equation of a line for this chapter, you may write it using point-slope form, and you can leave it in point-slope form. I will not make you solve for y. Okay? So, what is a hyperbola? This is what a hyperbola looks like, and you will see some similarities to that of an ellipse. We have a center. We have two vertex points, and we have two focus points. So we have two vertices and we have two foci, much like we do for an ellipse. When we get to the standard form of a hyperbola, you're also going to notice some similarities in the standard form of an ellipse and a hyperbola. So what is the definition of a hyperbola? We've talked about the geometric definitions for each conic section that we've discussed. Okay? The geometric definition of a hyperbola is, once again, very similar to that of an ellipse. So a hyperbola is the set of points in a plane where the difference of whose distances from 2 points is a positive constant. Okay? This is very, very close to that of an ellipse. With an ellipse, we talked about the distance to the foci when we add them. It is the same number. This time, we are taking the difference. Okay? Any point that lies on our hyperbola, if we take the distance to each focus, and we take the difference between those distances, it will be the same no matter what point we are talking about. Okay, so when we subtract the distances between the point to each focus, okay, let's say way over here, okay, distance here and distance here. If we take this first distance minus the second distance, it'll be the same as any other point. Now, when we talked about ellipses, we talked about a major axis and a minor axis. When we talk about a hyperbola, what we think of as the major axis in an ellipse, your book is going to call the transverse axis, okay? So on an ellipse, our vertices and foci lie on the major axis. In a hyperbola, the vertices and foci lie on the transverse axis, as well as the center. Okay, so when we talk about a horizontal versus vertical hyperbola, we're talking about this transverse axis. What line do all of these points lie on? The center foci, and vertices. So just like with ellipses, we are going to talk about the standard form of a horizontal and vertical hyperbola. Okay? When we talked about parabolas, we recognized a parabola by its equation because one of the variables was squared and one of them was not. Then we moved to ellipses and we talked about how both x and y were squared. Okay, the same thing is true for a hyperbola, except one of those is going to have to be negative. Okay, so let's talk about the standard form of a hyperbola. You will notice that it looks very similar to that of an ellipse, except we have subtraction in between x squared and y squared. Okay, so with a hyperbola, one of the squared terms is going to be positive, one of the squared terms is going to be negative. Okay, our center is still at HK. That has not changed throughout this unit. Okay. We have a new way of finding C. For a hyperbola, C squared will be A squared plus B squared. So now you're going to remember, you have to remember that difference as well. Okay. Now I do want to point out there is no mention of A being bigger than B. It does not matter which denominator is bigger. What is important here is that A squared will be under the positive variable, okay? So X squared is the positive variable, and then we're subtracting the Y squared, okay? Since the X squared term is positive, we write it first, and we know it's going to be horizontal. Okay. A is still going to tell us how far away our vertices are from the center. All right. And our foci are still going to be C away from the center. Okay. Since this is a horizontal hyperbola, we're going to plot vertices and foci horizontally from the center. Okay. Now, we are still going to need B, and we're still going to plot some points B away to help us draw our asymptotes. Okay, so you notice, I'm going to come right back, you notice that we had these asymptotes with our hyperbola. These are going to help give us our shape. You're not going to have to plot any extra points like we did with parabolas. What we're going to do is we're going to plot our asymptotes, and that's going to give us the shape of the graph. All right, so B is going to help us with those asymptotes, and we're going to plot B much like we did with ellipses, and I'll show you that when we get to an example. Okay. You will have to identify the equations of the asymptotes, and I'm not going to show you how to do that until we get to an example because I want you to draw the line and then write the equation. So we're just going to wait with that. Okay? I want you to think about what might be different between the equation of a horizontal hyperbola and an equation of a vertical hyperbola. I'm going to give you 20 seconds to talk amongst yourself about what you might think will be different. Okay, everybody back with me? How many of you said that the y squared was going to be positive? If you said that, then you are correct. Okay. Everything is the same except the y squared is positive and we're subtracting the x squared. Please notice how a squared stays with the positive variable. In a hyperbola, it does not matter which denominator is bigger. A is always going to be associated with the positive variable. So whatever is underneath of that y squared, that's going to be our a squared because it's a vertical hyperbola. Okay? And just like with a horizontal hyperbola, we are going to plot our center HK. We are going to plot our vertices A away. We are going to plot our foci C away. Excuse me. Okay. What you notice about this picture here, and we'll do this when we get to an example, but we plot our vertices A away, and then you'll notice how they have these 2 points highlighted here, and they've labeled them as B away. Okay, what they've done to get the asymptotes is they make a box, a rectangle, out of the A and B points, and through the diagonals of that rectangle, they draw asymptotes. Okay, so that is how we're going to draw our asymptotes. With our A and B points, which these points that are at B, they're not really even points on the graph, so anything that I do in green is going to be what you would do in pencil lightly. So when we plot those points B away, we can make a rectangle with the A and B coordinates, and then through the diagonals of that rectangle, we draw our asymptotes. Okay, I'm going to go through that again with our examples, but I just want to make you aware of what's going to happen. Okay. So here we go. Here is our first example. We have x squared over 9 minus y squared over 25 equals 1. I want you to think about what kind of hyperbola this is, horizontal or vertical. If you decided that this is a horizontal hyperbola, you are correct. The x squared is the positive variable, and we're subtracting the y squared, and so this is going to be horizontal. I know that 25 is a bigger denominator, but that does not matter in a hyperbola. What matters is who is positive. Okay, so this is a horizontal hyperbola. Okay, we need to identify our center. X squared, y squared. We are not subtracting anything inside of the square, so our center is at 0, 0. Okay. A squared is what is under our positive variable. So since 9 is underneath x squared, that means a squared is 9, and a is 3. So what we're going to do is we're going to plot points 3 away horizontally from our center, and then we are going to identify them. So our vertices are 3, 0, and negative 3, 0. Okay. Let's go ahead and identify B. B squared is what's ever under the negative variable, in this case 25. So B squared is 25, that means B is 5. What I'm going to do is I'm going to plot points 5 away from the center, just in the other direction. Okay, so since this is a horizontal hyperbola, I'm going to plot them vertically. And then what I'm going to do is, do you see how if we had an ellipse, we would connect all those four for a nice ellipse? That's not what we're graphing. We're graphing a hyperbola. What we're going to do is we're going to make a rectangle out of these points. Very, very lightly. This isn't a part of the graph. This is just a guide for us. Okay. Then, with every single hyperbola, our asymptotes are going to go through the diagonals. Okay? Which happens to also go through the center. So I'm going to draw a line through this diagonal, and then I'm going to draw a line through this diagonal. Okay. Those are our asymptotes. All right. That's what's going to give us our shape. So we know that a curve has to approach asymptotes. And so then we can get the shape of this hyperbola by making our curve approach those asymptotes. All right. Now we need to write the equation of those asymptotes. Remember, I want you to use point-slope form. This is what I'm going to ask of you. Identify your slope and use the center as the point. Both lines go through the center, so it's going to be easier for you if you use the center because it's the common point between both. So your lines are going to look similar. Their equations will. Okay? So our center is 0, 0. And if we look at our slope, we see that from our center to diagonal, we go up 5 and over 3. So our slope is 5/3. So we can say y minus y coordinate equals slope times x minus x coordinate. So the equation of that asymptote is y equals 5/3 x. Then we look at the other line. If we look from center to this corner, our slope is up 5, left 3. So this time our slope is a negative 5/3. Yes, that will happen every time. Your slopes should be opposite of each other. The last thing we need to identify are the foci. All right. Please recall that equation that I gave you. C squared is now a squared plus b squared. So in this case, we have 3 squared plus 5 squared. So 9 plus 25 make 34. So our C value is the square root of 34. Okay? Square root of 34 is almost the square root of 36. So we can approximate C to be almost 6. So I'm going to plot my foci almost 6 away from our center. So here's our center, 1, 2, 3, 4, 5, almost 6. And then the other way, 1, 2, 3, 4, 5, almost 6. Okay? And those points are 0, positive radical 34, and 0, minus radical 34. So you will notice that aside from having to plot and name our asymptotes, the process is very similar to that of an ellipse. It is not the same, but it is very similar. Let's try another example. Okay, now not every time will I give you a hyperbola in standard form. Okay, what I want you to take note of is how we know that this is a hyperbola to begin with, even though it is in general form. Okay, first off, we know it's not a parabola because there's an x squared and a y squared present. Second of all, I want you to notice how the y squared is positive, but the x squared is negative. That is tipping us off that, hey, we do not have an ellipse, we have a hyperbola. If both of them are the same sign value, like both of them are positive, we have an ellipse. If they are opposite sign value, we have a hyperbola. Okay? So we are going to need to complete the square 2 times so we can get the x minus h squared and the y minus k squared. Okay, so let's first focus on our y's and group those together. We cannot complete the square with a 16. So we're going to have to factor out that 16 from the y squared, which means we're going to have to factor it out of the 64. Then we need to group our x's together. We cannot complete the square with that negative in front of the x squared. So we are going to have to factor out a -1 out of the x squared term and out of the positive 2x. Then just like with an ellipse, we should move the constant over to the other side, and we'll balance our equation by adding the constants over there. Okay? In this first parentheses, 4 completes our square. However, we are not adding 4, we're adding 4 times 16. So to balance our equation, we will add 64 to the other side. In our second set of parentheses, 1 completes our square, but please be careful, please be careful. We are not adding 1, we are really adding a -1. Okay? This is going to be something that's going to be easy to overlook when you're writing an equation of a hyperbola. So please be careful that you keep in mind that there is going to be that negative there. So what we have is 16 times y plus 2, the quantity squared, minus 1 times x minus 1, the quantity squared, equals 16. Then, just like writing the equation of an ellipse, we need this to equal 1. So I'm going to divide by 16, and we have y plus 2 squared. I'm going to go ahead and write over 1, even though we wouldn't need to, but it's going to make it easier for us. X minus 1 squared over 16 equals 1. So now you'll notice we have a vertical hyperbola. Because the y squared is the one that's positive, we have a vertical hyperbola. Okay? And because 1 is under the positive variable, a squared is 1. So a is 1, and b squared is 16, so b is 4. Okay? Let's go ahead and identify the things that we need to. Our center is 1, -2. Please also be careful here. I know that the y squared comes first, so you're going to want to pick that -2 first, but please choose the x and then the y coordinate. So 1, -2 is our center. Okay? Now, we've identified a to be 1. We need to move vertically a because that is what kind of hyperbola we have. So here are our vertices. So our vertices we plotted at -1, -1, and -1, -3. Okay? Very, very lightly, I'm going to go ahead and plot point B away. So I'm going to count 4 horizontally. 4. That way I can make our rectangle very, very lightly. And you may even get to a point where you don't need to draw the rectangle, and that's fine. But please be very careful and be very precise when you're drawing the lines of your asymptotes. Okay? So now we need, I'll do this in right so you can see better. Our asymptotes to go through the diagonals, which will also hit through the center. And so, that's going to bother some of you, and it's going to bother me. Let me fix that. So we have our asymptotes drawn in, which means we can draw our hyperbola. And we're going to let that hyperbola approach those asymptotes. Okay. Now let's write the equations of those asymptotes. I'm going to move this down just a little bit. Oh, that's good. Okay. So you want to use the center as your point, and you want to count the slope. So I see from center to corner, our slope is up 1/4. So our slope is 1/4. So we're going to take y minus y. So since our center, our y coordinate is -2, we're going to take y minus -2 equals slope times x minus x coordinate of 1. And then I'll notice our slope from center to the other corner is up 1 left 4. So it has -1/4 as the slope. Okay, so those are your two asymptotes. Last but not least, we need to identify our foci. C squared is a squared plus b squared. We've identified a to be 1, so a squared is 1. B is 4, so b squared is 16. C squared is 17, so c is the square root of 17. We know that square root of 17 is going to be just a little bit more than 4 because the square root of 16 is 4. So I'm going to count 1, 2, 3, 4, a little bit more and plot my focus. And then from the center, 1, 2, 3, 4, a little bit more and plot another focus. So I'm going to label our foci as, let's see, we moved vertically. So from our center, our y coordinate changed. We added radical 17 to our y coordinate, and then we subtracted radical 17 to our y coordinate. Okay. That, ladies and gentlemen, is how you graph hyperbolas. I would like you to use the rest of the time to work on your homework. Please work together. If you have questions, work them out with each other. Ask questions if you need to. Here is your assignment. I look forward to seeing you on Monday.